we would call these the data values. So this was actually recorded. So this is recorded data right here. And then the predicted revenue is coming from the function right here. So it's the predicted values found by using f of x. So ideally, what they're asking us to figure out is how well does this function right here represent the actual data? So if you guys have done scatter plots and you had to draw in a line of best fit, how good of a line did you come up with? That's what we're trying to figure out. How good is this function to represent this data right here? So we have this idea of a residual. That was in our vocab, so let's just take a look at what residual means again. So a residual is equal to the data value, in this case, these numbers right here, data value minus predicted value. And the predicted value is this column right here, and that comes from our function. So what we're going to do is we're going to add in a column to our table, and we're going to find the residual for each data point. So all we do is we take our data value and we subtract the predicted value. So we have 745 as the data value. We're going to subtract 750 and we get -5. So the residual at x equals 0 is a -5. I'm just going to go ahead and fill in the table real quick. We're going to do the subtraction for each data point and then we'll see what that means. So when x is a 1, we take our data value 846, subtract 833, and we get a +13. We take 910 minus 902, we get a +8. 952 minus 957 is a -5, and 1008 minus 988 is a +10. So what we do next, just to help us figure out how good of a, how well does the function represent the actual values, is we are going to make a scatter plot of the data and graph the function f of x equals -7x squared plus 90x plus 750. Remember, this is the function that the director came up with. That's where we got all of these predicted values right here. If you plug in a 4 to your function, we got back that 988. So I'm going to color coordinate this. I'm going to make a scatter plot of the data in red, and then I'm going to do the function in blue. First thing we're going to do is label our x and y axes. I'm going to count the y values by 50s, but our smallest y value is 750. I am also, by the way, I am plotting the scatter plot of the data. So if we look at our table, the scatter plot is the data value. So these are the x's, these are the y's. So we're plotting these ordered pairs. This is what actually happened. So back to counting by, or I'm going to count by 25s, and I'm going to start at 750. If it will let me. There we go. And then counting by 25s, that puts 750, 775, here's 800. And if I go up 2 more, I'm at 850. Go up 2 more, I'm at 900. Go up 2 more, we're at 950, and go up 2 more and we're at 1,000. I'm going to count the x-axis by halves. So this will be 0. 1 is going to be 2 spaces away. 2, 3, 4, 5. Okay, so in red, we're going to plot the data from our table of values. So the first ordered pair is 0, 745. So I'm going to go 0 up to 745 is going to be right about there. Our next ordered pair is 1, 846. So over 1 up 846 is about there. It's pretty close to 850. 2, 910. So I'm going to go over 2 up 910. And then our next ordered pair is 3, 952. So over 3 up 952. And then over 4 up 1008. All right, now I'm going to take my blue pen and I'm going to plot the points for this. And I'm actually going to draw in this function once we plot it. So these ordered pairs are going to come from the same x's, but now we're using our f of x function, the predicted values that used f of x. So I'm going to do 0, 750 as an ordered pair, 1, 833 as an ordered pair. I'm going to do this in blue. So the first ordered pair is 0, 750, which is right there. Next we have 1, 833, which is about there. 2, 902. 3, 952. Oops, should be 957, excuse me. 4, 988. About there. And I'm noticing right now that this red dot is in the wrong spot. It should have been over at 4. So I'm going to fix that real quick. So these points are all kind of close together, but I am going to go ahead and sketch in the function going through the blue points. We can see there's just a little bit of a curve to what that looks like. So at a glance, it looks pretty decent, right? Like this function right here seems to model the pattern of points pretty well. It seems to be going not through every single exact point because that's not possible, but it's going kind of through the middle of them. So what we do next is we're going to graph the residual plots and describe how well the function fits the data. So when we graph the residuals, what we're doing is we're keeping our x values. So the first x value was 0, and that residual we came up with, so 0, the residual that went with that was -5. So we're going to plot that as an ordered pair. When x was a 1, the residual was a +13. And I'm just getting these from our table up above. When x was a 2, our residual was 8. When x was a 3, the residual was -5. When x was a 4, the residual was 10. So we're going to go ahead and plot those points. Oh, we're going to have to label our axes. So I just counted the y-axis by 2's. So 2, 4, 6, 8, 10. Let's see, we have to go all the way up to 14. 12, 14. And then the negatives, -2, -4. And then the y, or the x's, I just counted by 1's. So I'll just make a note, count by 1's, because it's going to be kind of a pain to write those in. All right, so let's plot these points. 0, -5 is right here. When our x was a 1, our residual was a +13, which is up here. When x was a 2, the residual was 8. When x is a 3, the residual was -5. And when x is a 4, our residual was 10. Okay, so essentially what we're looking at is how far off from the data were the residuals. When these numbers are smaller, that means that that difference was smaller. So our predicted value was much closer to the data value. So we can see how far above or how far below the x-axis these residual points are. And that's going to help us determine how accurate our predicted model is over here. So what we notice with our residual plot is we have, let's see, 1, 2, 3, 4, 5. We've got 3 residual points above our x-axis and 2 below. So that is, it's decently split between, the positives and the negative residuals. So here's how we would conclude this whole thing. Almost done. The residual plot that's this right here, shows both positive and negative residuals. Which indicates a generally good model. And when we say model, we're saying function, that f of x function that the director came up with. How good of a model or predictor was that? It's pretty decent. Now, if all of our residuals had been positive up here, that wouldn't be good. It wouldn't be a good predictor. If all the residuals were negative, that wouldn't be good. So you want to have, residuals above and below, positive and negatives. That's why this blue function over here is kind of going through the points. Some data values are below it, some data values are above it, and that's good. That's good when it looks like this. It indicates a generally good model.